practice quizzes. All right, so here we go. Now, on your colored sheet, remember we boxed in the ones that we're using, right?
Yeah.
So look at those boxed in ones and see if anything up here, if any of that looks like it, I can use something on my colored sheet for it.
Yeah.
What?
The 1 minus 2.
1 minus 2.
Wait, never mind.
We're looking in the
Sine,
box,
Sine, cosine.
right?
On the bottom.
Pretty kind of 1 minus cosine squared.
Well, on the bottom, isn't that 1?
Yes.
Isn't sine squared plus cosine squared equal to 1?
Page on the track.
Now, I'm not going to ask you how you know that, but.
Okay.
Okay, so the denominator is just 1. Now, what about the numerator?
This
This is
is number 20.
number 20. What about the numerator? Kids, look. 1 plus tangent squared is secant squared, right?
Yeah.
What happens if I subtract this guy over to this side? What would that equation say if I subtracted that over? It equals 1. It says 1 equals secant squared minus tangent squared. So that numerator is 1. So I have 1 over 1, which is just 1. Hi, do you ever pass? So yesterday, or whatever day we did this, we talked about how these identities that are written on the paper, on your colored sheet, usually they don't just look the same as they look on the sheet. Now this one does. That's 1. That's on the sheet. But some of the other ones, you have to rearrange things. And that's what's going to happen here. What's 1 minus cosine squared? It should be written on your paper. What's 1 minus cosine squared? Sine squared. So the denominator is just sine squared. Now be careful with the numerator. Sine squared plus cosine squared is 1. That's fact. That's on your sheet. Cosine squared is 1 minus sine squared, right? But this is sine squared minus 1. This is backwards of what I need. So I want you to think about what happens when you subtract backwards. What's the difference between 7 minus 4 and 4 minus 7? One of them is negative. So if you subtract this backwards, sine squared minus 1, then you're not going to get cosine squared, you're going to get negative cosine squared. Because you subtracted in the wrong order. This one's okay. This one's subtracted right. If you look on your paper, it says 1 minus cosine squared equals sine squared. And if your paper doesn't say that, it's because you didn't write it down when I told you to. Because I told you to write this down twice now. 2 days I've asked you to do that. So 1 minus cosine squared is sine squared. But if you subtract in the other order, like this one is backwards, it's negative. What's cosine over sine? What's it say on your paper? Cosine over sine.
Where are we at?
We are finishing the last problem on the extra practice sheet. That's cotangent. So we're going to have negative cotangent squared, Roxy. That's going to be our answer. negative because of the negative sign, and it's cotangent squared. Okay, so now we finished that. And we're gonna do the practice quizzes, which are a part of the same packet. So let's look at practice quiz 1, which has 2 problems on it. Practice quiz 1 in the same packet as we were just working. And we're going to simplify this. Now, we did a whole bunch of these yesterday. What strategy did we use when we simplified a big long string of stuff like this with no pluses or minuses, just a big long string? What did we do? Changed them all into fractions. So sines and cosines. What's cotangent? Cosine over sine. What is, well, sine we don't change, right? So I'll just write it sine over 1. What about secant? 1 over cosine. And what about tangent? Sine over cosine. So once I get them all changed, then I just stand back and start canceling?
Yeah.
So here goes, here goes. What am I left with? Tangent. So that all simplified to just plain tangent. Sine over cosine is tangent. All right, that wasn't so bad. Let's look at the second one. Now, this one, when you did this one, if you were looking at your colored sheet, weren't you looking at these top 5 right here? But now for this one, you're going to look at the next 3. If you do not like the theta, feel free to change that to an X or something. Okay, you don't have to use the same letter, you can change it. Okay, what occurs to you when you look at this? We've talked about it already today. What's 1 minus cosine squared? 1 minus cosine squared is sine squared. So you've got sine squared over sine. What happens? You can cancel one of them out and you're left with just sine. That's the quiz you're going to take next time we're in person. That's it. All right, let's practice another one. Number 2, practice quiz number 2. All right, take a look at it. What occurs to you when you look at this problem? What do you notice? You're looking at your colored sheet also. You're going to have your colored sheet for the quiz. What do you notice on the colored sheet? What does it say? 1 plus tangent squared is secant squared. So we have secant over secant squared. Okay. What happens now?
Cancel out.
And what would it cancel? What would you have when you cancel? No, you won't have
No,
secant.
no,
You'll have 1 over secant, right? When you cancel, be careful. If the leftovers are in the bottom, make sure you're doing 1 over. Here the leftovers were in the top. Here they're in the bottom, so I have to do 1 over. It's 1 over secant. What's the reciprocal of the secant? That's cosine. 1 over secant The reciprocal of the secant is the cosine. What about number 2? Here we go. We're looking at the top 5 on our sheet. We're turning them all into fractions so we can cancel them. Don't change a cosine. I'm going to make it cosine squared over 1. If you want, you can write that as cosine over 1 times cosine over 1. Right? If you want to write it twice, you can. We don't change a sign. What about secant?
1 over cosine.
1 over cosine. And what about tangent?
Sine over cosine.
Sine over cosine. Will these cancel with those?
Yeah.
Will these cancel?
No.
No, because they're both on the
Top.
top. So I guess we have sine squared left, right? Sine times sine? Got it? All right, there's one more practice quiz. Quiz has 2 problems. One of them's like this and one of them's like this. So let's see what we've got on the 3rd practice quiz. All right, let's change them all into fractions. Here we go. Sine squared stays sine squared. What's secant squared? 1 over cosine squared. What's cosecant? 1 over sine. And cotangent? Cosine over sine. Is that all right with everybody? All right, we'll cancel, so here we go. There's 2 signs right there, so those are gone. There's 1 cosine, so we're still gonna have 1 left in the bottom.
There's 1 over cosine.
And we end up with 1 over cosine. And what's 1 over cosine?
Secant.
Secant. That kind's easy, especially with the other colored sheet, right? All right, let's take a look at the next one. Ay, 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 this looks a little harder. Okay, don't let the thetas bother you. Change them to x's if you want. What occurs to you to do? Could you factor? Yes, Creighton, you're awesome. You can factor. Don't we have a common term here, guys? So let's take out the sign and let's see what's left if we take it out. What's left if we take it out? 1 minus sine, oh my gosh, 1 minus sine squared. Wait a minute, I've heard that before. What's 1 minus sine squared? Cosine squared? So I have sine times cosine squared over cosine. Can I do anything with that? I can cancel out a cosine. And my final answer will be sine times cosine. Okay, those, I put these in Schoology, so if you wanna practice them again on your own, feel free to do that. Alright, now I need to find my notes. We are totally shifting gears now, totally. You can put away, actually, you can leave the colored sheet out, I guess it's got something on it that we need. And get your calculators out, because we are about to embark on a very fun experience. We're gonna solve some triangles. Now, I want you to think about something for a second. You don't have to write this down, this is not on your paper. I want you to think about the tests that you took. And there were problems on the test that looked like this. I'm making up the numbers, but they look like this. And you had to write an equation and figure out what x is. Remember that? So you looked at that triangle, hopefully, and said, okay, this is the opposite side, this is the adjacent side, and this is the hypotenuse. And since I don't know anything about the hypotenuse, since I've just been talking about opposite and adjacent, I'll use tangent and say tangent 42 equals opposite over adjacent. Hopefully that looks familiar. That's what we did in chapter 4. Now, every triangle we looked at in chapter 4 was a right triangle. And so you were always able to identify opposite, adjacent, and hypotenuse, because it was a right triangle every time. So you were using SOHCAHTOA every time to solve the right triangles, and that's exactly what you should have been doing. But SOHCAHTOA only works in a right triangle. What's the H stand for? Hypotenuse. And if you don't have a right triangle, you don't have a hypotenuse, right? So SOHCAHTOA is not going to work on problem 5.5 1A. I want you to look at problem 1A. These are your notes. 5.5, number 1A, it says solve the triangle. But the triangle does not have a right angle. It has angles and sides, but it doesn't have a right angle. So this is not going to be done the same way you did these. No SOHCAHTOA. No opposite over adjacent, opposite over hypotenuse, none of that. We're going to learn something new today, and it's easy and fun. You need a calculator. Before we do that, though, I want to make sure we understand that when we label a triangle, I can't remember if we talked about this before, when we label a triangle, we use capital letters for the angles, and we use lowercase letters for the sides. So across from angle A is side A. Across from angle C is side C, and across from angle B is side B. That's the way we label triangles. So capital letters for the angles themselves, and then lowercase across from the angle. okay? To solve this triangle, well, first of all, can you tell me what angle B is? Can you figure that out? Oh, I hope so. What do we know about the angles of a triangle? They add up to 180. So if we know one of them's 70 and one of them's 38, then we should be able to find the other one, 72 degrees. So your job in this problem, you can see over to the side, your job is to find all the missing pieces. So we had to find angle B, side B, and side C. Well, angle B is a no-brainer. It's 72 degrees. We don't need to be in Precal to know that. Now, what about these sides? Well, we're going to use what's called the law of sines. And the law of sines is a proportion. Very easy, a proportion. The law of sines says that the sine of angle A over side A, remember that's the angle, that's the side, is the same as the sine of angle B over B and the sine of angle C over C. That's the law of sines. I actually wrote it on your colored sheet. So in this triangle, could we say that the sine of 38 over 16, the sine of 38 over 16 equals the sine of 72 over B? See how easy that is? That's easy. Now, I can't do the third one. I can only do two at a time. There'll be another step where we'll find the third one. But would you agree right here? How do we solve a proportion like that? How do we solve something like that? Cross multiply. So 16 sine 72, I'm cross multiplying. So 16 times sine 72 equals B times sine 38. I'm simply cross multiplying. And then, how will I get B by itself? What will I have to do to get B by itself? Divide by sine 38. So I am going to go to my calculator and I'm going to type in 16 sine 72 divided by sine 38. Now, let's do this carefully. First, I got to go to mode and make sure I'm in degrees, which you probably are, but just in case, double check. Make sure you're in degrees. And then 16 sine 72. Now, did you notice when you hit sine 72, it put in parentheses? Close them, and then divided by sine 38. Do not forget to close those parentheses. What did you get for side B? 24.72. I rounded off to the 100. Now we still need side C. All right, so you're going to set up another proportion. Does anybody have a thought on what the proportion will be to find side C? Sine 38 over 16 equals sine 70 over C. Does that make sense to you? Now, let me caution you. Sometimes kids want to use this one and say sine 72 over 24.72. Don't use that one unless you absolutely have to, because that's rounded off. And if you use a rounded off number in your equation, it's going to throw you off a little bit. So let's let's go back and use sine 38 over 16, those aren't rounded off, and sine 70 over c. All right, let's cross multiply, here we go. C sine 38 equals 16 sine 70. C times sine 38 equals 16 times sine 70. And some of you are already typing. We have to divide by sine 38, right? So C equals, whatever that is, 16 sine 70 close parentheses divided by sine 38. You get 24.42. Does it make sense that these two sides are so close? They're not equal, but they're very close to each other. Does that make sense? Why? Because the angles are almost equal, right? The angles are almost equal. If the angles are equal, the sides are equal. Well, the angles are close, so the sides are going to be close. You just did your first law signs problem. Easy. We love our law signs. There's just one bad thing about it. We'll get to it later today here, I think. But usually the law signs is super duper simple. All right, let's try the next one. Do you think you can do it on your own?
One more.
Well, those of you that can do it on your own, go ahead. Go right ahead. I'll walk through this with the others. All right, so we got triangle DEF. And this is 48, and this is 71, and this is 8. And I have to find angle D, side E. Remember how we label, this is side E, and this is side F. Solving a triangle means finding everything that's missing. So what's missing here is angle D, side F, and side E. All right. D is easy. What's angle D?
61 degrees.
What is it?
61 degrees.
61? Is that right? Somebody check that. Is that right?
Yeah.
Okay, perfect. So that's a 61-degree angle. Good. Now we're going to set up a proportion. And when you set up the proportion, you have to use the two that you already know. So in other words, I have to use this, my pair, D and D. I got to use these. So sine 61 over 8. When you set up your law of sines, you can't have variables in both fractions. You can only have one variable. So that means one of your fractions has to be complete. And then the other fraction can have a hole in it. So maybe you say sine 48 over E. See how that's got an unknown in it? You can only have one unknown. So you have to use sine 61 over 8. All right, cross multiply, here we go. E sine 61 equals 8 sine 48. E times sine 61, 8 times sine 48. And then 8 sine 48 divided by sine 61. Are you keeping up with me? So 8 sine 48, close parentheses, divided by sine 61. For side E, I got 6.80. Does that sound right? Now I'm gonna set up another proportion. I'm gonna go back to sine 61/8. I'm gonna use that again. And this time, what's it gonna equal? Sine 71/f. So f sine 61 equals 8 sine 71. 8 sine 71 over sine 61. I'd like everybody to type that in, please. Some of you are just like watching and listening. Let's all type that in just to make sure that we're all getting the same answer. I got 8.65. Everybody get that? Now, if you look at the next problem, you'll notice I didn't draw the picture. That means you have to draw it yourself. So remember how I told you to draw your picture. We have angle A, B, and C, and I don't care where you put the A, B, and C. That's irrelevant. So just pop an A, B, and C on those angles. This is triangle A, B, C. Now, if angle A is 42 and B is 73, and then side A is 6, you gotta get that in the right spot. Side A goes across from angle A, so this is 6. This down here, the way I have set my picture up, this down here would be side B, and this over here is going to be side C. Is that, everybody got that? Because if you don't set your picture up right, you might have the wrong equation. Probably will have the wrong equation. All right, last call. That picture okay with everybody? That's what you've got. All right, see if you can set up your law signs. For this problem, see if you can set up the proportions for this particular triangle. I'll do it too. We'll see if we get the right or the same answers. Okay, Josh, you want to open your eyes, sweetie? Get started. Yes. Do you have to go to the nurse?
No, just the bathroom.
Dave, you got this done? Nope. Get up, sit up, get it done.
Do the triangle.
That's good, we're solving it now.
Yeah.
Okay, so set up your proportion, cross multiply, divide, and type it into the calculator.
Ma'am.
Twice. Once for side B and once for side C. And don't forget to find angle C while you're at it. don't match, let's talk about it. So what do you think? Did anybody get, first of all, which angle did I have to find? Did anybody get 65?
Yeah.
Okay. How about 8.13 for side C across from the 65?
Yeah.
And 8.58 across from the 73? So we're feeling good about our law of signs, right? Okay. So now we're gonna look at when the law of signs is a little problematic. Usually it's easy. Everybody loves the law of signs. It's easy. But there is one situation where it can be a little bit hairy. So I'm gonna look at that situation. And what I'd like for you to do is to tell me if you notice what's a little different about this problem. It only gives you one angle. Only one angle. When you're only given one angle in a law of signs problem, it's called the ambiguous case. And it's ambiguous because we're not sure if there's going to be one set of answers or two sets of answers or no answers at all. It's ambiguous. Tying this into what you remember from geometry, I want you to look at the triangle. Okay, the triangle that we were given in the last problem, the information was an angle, and a side. Back in geometry, you called that AAS, angle, angle, side. Remember doing the proofs? And you had to prove all this stuff, and then in the end it was SSS or SAS or something like that? Well, there was one combination of letters that you weren't allowed to use because it made a bad word. There was no ASS. Do you remember that? You couldn't do ASS because it made a bad word. Well, take a look at what I have here. I have angle, side, side. This is an ASS triangle. And when you have that situation, only one angle in a law of signs problem, then you're going to have potential issues. All right, so here's how we handle it. I promise I am not going to sneak this problem in. The directions are going to say how many triangles are possible. So it's going to clue you in. Okay, this is one of the weird ones. Here's what you do. You go ahead and set it up like it's a law of signs problem. So you would say sine 20 over 12 equals sine B over 31. Now, there's nothing tricky or hard about that. Agreed? That's the law of signs. The difference is the variable is an angle, okay? Because you only have one angle. So we're going to go ahead and cross multiply. So 12 sine B equals 31 sine 20. Regular cross multiply. And then we're going to divide both sides by 12. So it says sine B equals 31 sine 20 over 12. Remember, this is tied together. You can't split that. So you're going to divide by 12, and that's going to leave you with sine B. Well, how do we split that? There's only one way to undo that. Do you remember? How do we unhook those two? Exactly. So B is going to be sine -1 of this fraction. Let me erase some of this stuff. Just like you did in the last chapter, if you want the angle, you have to do second sine. So the only way to get B by itself is the second sine that fraction. All right, let's do it. Second sine 31 sine 20, close one parentheses, divided by 12, close the last parentheses. I got 62.07. Is that what you got? Let's type it again together. Everybody together.
Okay.
Second sine 31 sine 20, close parentheses once, divided by 12, close parentheses equals. You get 62.07?
Yep.
Yeah.
All right, now hang on. When the directions say how many triangles are possible, and we're going through this whole process, you got an answer. So now you have to check to see if there's another answer. Now, do not panic. I am simply recopying my problem. And if there is another answer, it will be 180 minus the one you just got. So it would be 117.93. So let me say that again. Once you type this in and get an answer, then draw your triangle, again, the original triangle with the 20 and the 31 and the 12. Draw it again. And the answer you got was 62. This is going to be 180 minus 62. Always, never changes. 180 minus 62. Now, it's kind of hard with our first example for you to understand what's happening here, but is it possible to have a triangle with a 20 and 117? It'll look weird, but it's possible. What would not be possible? Well, what if this were 80? Would it be possible to have an 80 and 117 in the same triangle? No, because that's more than 180. So sometimes that second angle isn't going to work. Depending on the size of the first one, sometimes the second one isn't going to work. But this does. How many triangles are possible? 2. One with a 62 angle and one with a 117 angle. Okay, I know that's a lot. We're going to do another one. When the problem says how many triangles are possible, the answers will either be 0, 1, or 2. This one has 2. Because both of these combinations work. Let's look at the next one. with me, guys. I know it's a little bit complicated. You'll get the hang of it. So A is 76, side A is 18, side B is 20. The directions say how many triangles are possible. That gives me my clue. It's another ASS triangle. So it's either going to be 0, 1, or 2. I don't know until I solve it. So what will my law of sines look like? Sine 76 over 18, sine B over 20. Okay, what's my cross multiply gonna look like? 18 sine B equals 20 sine 76. So then I'll divide by what? Just 18. You can't divide by anything else, guys. It's just 18. And it says sine B equals 20 sine 76 over 18. Now, type this in and you're just going to get a decimal. You're not going to get the answer. To get B, I want angle B. What am I going to have to type? How do I get that split apart so it's just B? Second sign. So I'm going to type in B equals second sign that fraction. Your calculator does the work. Second sign, 20 sine 76, close parentheses, divided by 18, close parentheses. Wait a minute, I gotta try that again. Okay, now wait a second. Remember when Mrs. Ford said that the answer to all of these problems is either 0, 1, or 2? The answer to this one is 0. It doesn't work. It doesn't work. So all that was wasted. There are no triangles. You cannot make a triangle that fits that information. All right? You're doing great. We're going to do one more. And that's it, one more. We'll finish the rest of these. Because there's some more. We're going to do one more, okay? So here we go. Problem C. Let's draw a picture. And set up our law of sines. So A is 85, A is 15, and B is 25. Okay, does that picture look okay to everybody? All right, so here we go. Who can set up the law of sines for me? Sine 85 over 15 equals sine B over 20. Perfect. So 15 sine B cross multiplying equals 25 sine 85. Be careful, what do you divide by?
15.
Just the 15. So now it says sine B equals 25 sine 85 over 15. How do I type that in on my calculator? B equals second sine this fraction. right, let's see if we get an answer. Last time we didn't. So second sign, 25 sine 85, close parentheses, divided by 15. Oh no, did you get another error?
Yes.
Oh, crud, I don't want to end on an error. We might need to do one more.
No.
We understand.
We get enough, we learned enough.
We learned enough
My
for
brain's
today.
fried.
Alright. Tell you what though, before we wrap it up completely, I want to do another practice quiz problem. Is that okay? Before we close up. So we'll stop with our notes right there. But let's do a quick practice quiz problem. Mrs. Ford, can I go to the bathroom?
Oh, stop. Why are you asking me?
Can't you wait a few more minutes?
I guess.
This is a quiz question. We're gonna have a quiz over this.
I was looking at it. You never get it, bro? He did not. He did.
Yeah, we're just practicing problems like we're gonna be on the quiz. Kai, would you sit down? We have a quiz and we're practicing for it.
Okay.
All right, this could be a quiz question. So what do you think? What occurs to you? Remember, you'll have your colored sheets. You can look that over.
Wouldn't that be sine squared? For the one?
This right here, very good, Ethan, that is sine squared. So we have sine squared plus sine squared over sine. All right, now what? Can't cancel yet.
You gotta take out the
Factor.
Don't make it harder than it is. What's 1 sine squared plus 1 sine squared? 2 sine squared, right? 1 and 1 makes 2. So this is 2 sine squared over sine.
Now you can.
Now you can cancel. Now you can cancel. You couldn't cancel before because of the plus sign. Now you can. So the answer is 2 sine. Roxy, this would have to be cosine squared plus sine squared. Right? No. School is going to be out in a minute. You guys can just chill. All right, so the quiz has 2 problems on it. One of them looks like that. The other one looks like this. What's going to happen here? I just started writing. All right, so this could be our other quiz question. All right, so what's tangent? Sine over cosine. Times, all right, what's cosecant? 1 over sine squared. Sine is just sine. Secant is 1 over cosine. And cotangent is cosine over sine. So Ethan's over there rattling this off. He's not even looking at his colored sheet because we've done so many. You're kind of getting the hang of it. Good. All right. Well, anything cancel?
The sine, the cosine.
Okay. Here's 2 sines and sine squared. Here's a cosine and a cosine.
One
1 over cosine sine. Remember, when the leftovers are in the bottom, you have to do 1 over. Don't just write cosine sine, right? That's your practice quiz.